Now, there is actually a general formula that we always can use when we find the primitive of these type of functions. For example, x3, x to the power 3. The primitive is you just increase this exponent by 1 and divide by that number. So in this case, we're just going to write out x, and then I'm going to increase 3 by 1, so we're going to get 4, and then divide by 4. That's it. Let's try another one. x5, its primitive is x, and I'm going to increase 5 by 1, so we're going to get 6, and then divide by 6. If I have, let's say, 3x4, the 3 stays, I'm just going to write it out, 3x. I increase the 4 by 1, so it's going to be to the power of 5, and then divide by 5. Okay, let's try a couple of more exercises. So the formula always works with these type of functions. So let's have a look at a couple more examples. For example, 2x3. The primitive of 2x3 is going to be 2x. I increase the 3 by 1, so it's going to be 4, and then divide by 4. Here I can actually simplify a little bit because we have a factor 2 up here, a factor 2 down here, so I'm just going to cross out 1 and then 2. If we write it out, it's going to be x4 over 2. Let's have a look at 4x3. Same thing, 4x. I increase the 3 by 1, so it's going to be to the power of 4, and then over 4 over this number. And here we can cross out the factor 4 in the numerator and down in the denominator. So I have 1, 1. So the answer would be simply x to the power of 4. Let's do one more. If we have, let's say, of course, if we have these type of functions, 3x2 plus x. We just apply the same rule to first this term, 3x2, and then the same thing for this term, x. So 3x2 is going to be bx, and then it's going to be 3 up here. The exponent is 3, and divide by 3. Then we can see we can cross out the 3's here. Let's do this first. Plus, and I'll continue on this page, x. It actually says x to the power of 1, right? We have to remember that. So x, and then increase 1 by 1. It's going to be 2 up here, and then over the new number up here. So x2 over 2. Now, can we simplify this? Of course. Let's see. 3 and 3, I'm just going to cross out. It's going to be 1 and 1. So it's going to be x3 plus x2 over 2. So once again, this is a function, f of x. Its primitive is this. And this is basically the inverse process of derivative, finding the derivative. we can always check the result if this is correct by just finding its derivative, and then we should get this, right? So let's do this. We don't have to write it out, it's easy. We know that the 3 goes in front, so it's going to be 3x and then to the power of 2. 3x to the power of 2. So this term is correct. The second term, the 2 goes in front, x to the power of 1. We're just going to write 2x over 2, and then we can cross out the 2's, so we have x, and that's the second term. So we can always double check that correct when we have a function and we find its primitive. We can just check if it's correct by finding this, the derivative of this, and if it's the same as the function, we know that the answer is correct.